In this video, I'm going to prepare you for group activity free and test free. So let's start going over. First of all, this link that you see here, this is a link for binomial probability distribution to make your life easier. There are problems in this practicing problems that you can use this calculator, plug the numbers, and not to struggle with so much calculation in there. Hopefully this will help. Okay, now let's start talking about our problems, practicing problems that's gonna help you through group activity and test. All right, so the random variable x has a normal distribution with standard deviation 24. It is known that probability x exceed 167 is 90. Okay, probability of x that exceed 167 is equal 0.9. So on the graph, it's gonna look like this. More than if this is our, how much is the average we need to find? Okay, assuming this is our 100, x is 167, exceeding 167, which is gonna be right tail, right? Okay, so we need to find average. All right, so first of all, to find the average, we need to find our z-score based on this probability. So z-score is equal x minus mu over sigma. Yes? Okay, so from here, from this formula, x minus mu is equal z sigma, and mu is equal x minus z sigma. This is the formula that we are going to use here. All right, so let's see how much is going to be our z-score. First of all, since we have greater than, that means we have right tail, yes? So to find the left tail, because our table shows left tail, what we have to do? 1 minus 0.9. We'll get 0.1, correct? So probability for x is less equal 167 is equal 1 minus 0.9, we get 0.1, which is 10%. Now we need to find z-score for this 0.1, for this 10%. Remind you real quick, so we are given probability, so you are looking 0.1, it's less than 0.5, which is 50%. So we are going to look in the negative z-score table, and once we find 0.1, right, we go horizontally, go vertically, and we should get negative 2.33. So negative 2.3 should be here, and 0.03 should be here. Once we have z-score, we can find out our mu. Mu is equal x minus z-score sigma. So our x is 167 minus z-score is negative 2.33 and times 24. Sigma is 24 right here. So, and the solution is going to be 167 will end up adding, because we have two negatives here, plus 30.84, and our mu is gonna be equal 198. Okay, let me move a little bit down. This is getting too much crowded. Okay, so Mu is equal 198. Okay, we solved the problem. We needed to find mu. Next one. About 20% of babies born with a certain ailment recover fully. A hospital is caring for 5 babies born with this ailment. The random variable represents the number of babies recover fully. Decide whether the experiment is a binomial experiment. If it is, identify a success, specify the values n, p, and q, and list possible values of random variables. Okay, so let's cover step by step. First condition for binomial distribution, it's gonna be if experiment repeat itself a fixed number of trials, and trials are independent. Do we have they repeat X number of trials? Yes. Represent number of babies that fully recover. So number, it's not number. It can be 7, 8, it can be 10, we don't know. But it's a fixed number, right? So, and they are independent. What happened to one baby has nothing to do with another baby. Okay, so it's a fixed amount of trial, and they are independent. Trials and independent. Okay, number 2. Let me write down amount readable. Number 2. There should be only possible 2 outcomes, the failure and success. Not literally failure of success. One answer we are interested, it will be success. The answer we are not interested, complement, will be failure. Okay, do we have it? Yes, some babies fully recover, some not. So yes or no question. So 2 outcomes total. Number 3. The probability of success is the same from trial to trial, and it's because it's independent. Okay, 20% of babies. So if this baby will survive, it has nothing to do with the other baby, right? So yes, we have probability of success. And number 4, it's going to be random variable x that counts the number of successful trials. Here it is. List the possible, where is it? The experiment is binomial experiment. 20% of babies with a certain ailment, here it is. Certain ailment recover fully. So it's a certain amount of X that are successful amount, successful trials. So it is binomial. Okay. Moving to number 3, exactly the same way we need to find if it's binomial or not binomial. So, what does it say also? If it is, then identify success, specify the values of n, p, and q, and list the possible values of random variable. Okay, so 20% probability of success, right? It's our 20%. Okay, with a certain hospital is carrying 5 babies, so our n. So this is a p we found. Now our n, it's gonna be 5, right? Carrying 5 babies. Carrying 5 babies. Okay, we got that one also. Here it is. 20. What else we need to find? Q. Q is very easy because if we have P, Q, it's going to be equal 1 minus P, right? So it's going to be 1 minus 0.2. It's going to be equal 0.8. So, all right. Next one. So, survey asked 1,000 workers. Has the economy forced you to reduce amount of vacation you plan to take this year? 55% of those surveyed said they reduced. Okay, 55%. That's going to be probability of success. 57%, I'm sorry. Then, which is 0.57. Okay. Then N, total survey, 1,000. Okay, we have that. So then Q is going to be equal 1 minus 0.57, right? It will be 0.43. Okay, well, let's see. First one, trials are fixed or not? Yeah, 1,000 workers. What will do one worker has nothing to do with the other one, right? Okay, so fixed and independent trials. Independent trials. Number two, how many possible outcomes do we have here? So the workers that are reducing amount of vacation and workers that not reducing amount of vacation. So yes or no question, correct? So we have probability of success and we have probability of failure. Okay, question number 3. The probability of success is the same. Okay, percentage is gonna be the same because based on 57% of those surveys said they reduced amount of vacation. So every time when you're questioning, there is a 50% chance, right? It either reduced or you didn't reduce. Let's say I reduced my vacation, you didn't reduce your vacation. So 50% chance, okay, when you are asking. So probability of success is the same for each trial. Okay, what else? And the fourth one, number of successful trials, 57%. It's number of successful trials, right? If 57% successful trials, and we have n percentage, so successful trials can be either between 1,000 and 0. So we need to find 57% of it. So that we have to do calculation, but we have steady successful trials from one trial to another. So it is binomial distribution. Okay. By the way, see, this is question 1, question 2, question 3. Okay, question 4. Let's move to question 4. Okay. Let's see what we have here. 29% adults favor the use of unmanned drones by police agencies. 12 U.S. adults are randomly selected. Find the probability that the number of U.S. adults who favor the use of unmanned drones by police agencies is exactly 3, B, at least 4, and C, less than 8. Okay, so what do we have? N, we have total how many? 12. There we go. N is equal 12. What else we have? Probability we have of success 29%, which is equal 0.29. Then probability of failure, it's going to be 1 minus 0.29, which is equal 0.71. Okay, so let's find the probability of success for free people find the probability number of US adults. So free people favor. Okay, so this is going to be, remember the formula, n factorial, and this link I posted at the beginning, that link for this binomial distribution. All you're gonna do, plug n, x, and probability of success, and it will give you the answer. So that's gonna be, oh, hold on, times probability of x, q, n minus x. So if you plug all your numbers, it's gonna be 12 factorial, 12 minus 3 factorial, and 3 factorial. So times 0.29 to power 3 times 0.71 to power 9. If you solve all this, you are going to get, and if you are calculating by hand, you cannot, the round numbers, you have to keep all 6-digit numbers. So since I did it by hand, let me go ahead and show you. That is equal 12 times 11 times 10 times 9 factorial, and here we have 9 factorial, 3 times 2 times 1. So 9 factorial is gone with 9 factorials, 3 is gone with 4 here, and we are times 0.29 to power 3 times 0.71 to power 9. So this is equal. So 4 times 11 times 10, it will gonna be 220 times 0.024389 times 0.04588485, and we will get probability x is equal 3. It's going to be equal approximately 0.246. 0.246. Next, B. So that was A. Now let's solve for B. What is our B? At least 4. So probability for at least 4, meaning greater, equal 4. That is equal 1 minus probability of 0, probability of 1, probability of 2, probability of 3. Okay? So why? Why is that? Because, look here. 0, 1, 2, 3, 4. We need 4 and more, right? So which means the total, it's going to be 100%, and we are doing minus all these 3, right? Because it's asking for 4 also. 4, we have it. This is 1, 2, 3, and this is 4. Okay, so this is going to be, no, 1, 2, 3. Okay, hold on. 1, 2, 3. All right. So that's why we take 1 and subtract 0, 1, 2, 3. And the result is going to be is equal 1 minus 0.01640968. I calculated everything by hand, plus 0.08043056 plus 0.18068555, and lastly plus 0.246038. And what do we get? Probability of x greater equal 4 is equal 0.476. Okay, so that was B. Number C. This is now our B. Let me highlight and this is our C. So what is our C? Less than 8. All right. Probability less than 8. Less than 8. It's going to be 12 factorial over 12 minus 8 factorial times 8 factorial and times 0.29 to power 8 times 0.71 to power 4. Because n is 12 minus x is 8, it's going to be 4. All right. What we are going to get here, if you plug all these numbers, so I'm not going to torture you writing all these 6 digits, I did calculate. Now just put the answer, it's going to be 0.006292, which means approximately probability of x less than 8, approximately 0.006. Okay? All right. D, this is number C. Do we have D? Oh yeah, less than 8. Since we have less than 8, so we need to find, hold on. Let me write down here, explain to you what we are going to have. Okay, we need to get less than 8, right? So this is what we have, it's equal 8. Because I plug specifically 8. So, but to find probability x is less than 8, what I'm going to do, I'm going to subtract, take 1 minus probability of 8 plus probability of 9 plus probability of 10 plus probability of 11 plus probability of 12. Okay. So we need to find, we found 8. Now we need to find probability of 9, 10, 11, 12. That's why to save your life, I gave you that link so you can plug all your probabilities and get the numbers and expedite the solution. Otherwise, you won't finish within 1 week, all these calculations. Okay, probability for 9, it's going to be equal 12 factorial. 12 minus 9 factorial, 9 factorial, and times 0.29 to power 9 times 0.71 to power 3. And the answer is 0.001142. Probability of 10 is equal 12 factorial, 12 minus 10 factorial times 10 factorial, 0.29 to power 10 times 0.71 to power 2. And that is equal 1.399718. Next, probability of 11. That is equal 12 factorial, 12 minus 11 factorial times 11 factorial, and it's times 0.29 to power 11 times 0.71 to power 1, and we get 1.039483. And lastly, if you punch the numbers for 12, you will get 3.538147. And finally, probability of x is less than 8. It's going to be equal 1 minus probability of 8 plus probability of 9 plus probability of 10 plus probability of 11 plus probability of 12. I believe you can do it, right? You don't want me to sit down and subtract all these values, probabilities that you have. You need to always subtract from 1, add together and then subtract to 1. That's it. There is not a big thing in there. 9, and where is our 8 is 0.06. Okay? All right. Question number 5. This was number 4. Moving to question number 5. Okay. Let me move this one a little bit here. So, question number 5, what do we have here? 71%, it is, of adults in a certain country believe that life on another planet is plausible. You randomly select the 5 adults and ask them whether they believe that life on another planet is plausible. The random variable represents the number of adults who believe the life on another planet is plausible. Find the mean and standard deviation, of the binomial distribution for the random variable. Interpret the result. So 71% is, we got it from here. And your life is, you randomly select 5 adults. Here it is. All right. So to find mu for binomial distribution is pretty straightforward. Mu is equal n times p, which will be 5 times 0.71, because 71% is 0.71. And we get 3.55. Q is equal probability of failure 1 minus 0.71, which is going to be 0.29. Why did we calculate? Because we need to find standard deviation. Standard deviation, we are going to go through variance, right? You have to find variance and then square root. So variance is n times p times q, which is going to be 5 times 0.71 times 0.29, and it's going to be 1.0295. And standard deviation, sigma, it's going to be 1.014642. Let me tell you something, how I am figuring out which one to solve, what to solve. So first thing, what you want to do, look what you need to find. You need to find average, you need to find sigma. And right away, writing down formula for average. What's the formula for average? M is equal nu n times p. I'm looking, do I have n? Yes. Do I have p? Yes. Which means I'm done with mu. I can find mu easily. Next, sigma, standard deviation. So we need sigma squared, right? Variance. What's the formula for standard variance? Sigma squared is equal n times p times q. Let's see, do I have n? Yes, I do. I have p, probability of success. Yes. Q we can find out. Here it is, very easy. And plug numbers. That's how I'm doing. Okay. Number 6. Find the area of the shaded region under the standard normal curve. If convenient, use technology. So we're going to use table. Okay. So between, we have to find this shaded region So practically we need to find probability of for z-score negative 2.06 and then probability for z-score equal 0. Once we find for negative 2.06, it's going to be this area, right here. And for probability of 0, it's going to be this area and coming all the way, overlapping all the way to the end. So again, if I take this piece, right, area, and subtract this piece, right, so I will get this piece that we are interested to know, this piece, so this area. Okay, let's see. Let me clean so you will see the true face of the problem. Here we go. So probability for z-score that is equal or less than negative 2.06. So I'm not going to bring here table because you already know how to work with it. All I'm going to show you, you are going to negative z-score because you have negative. So you find negative 2.0 and here 0.06, and intersection should give you 0.0197. Okay, now z-score is equal 0. When probability z-score is equal 0, that's an average, which is going to be 0.5, 50%. And to find the probability of shaded area, we need to subtract from each other. So 0.5 minus 0.0197, and we get the answer 0.4803. So what we are doing here, practically probability of z-score less equal 0, we put here less equal, minus probability of z-score less equal, let me move this, getting crowded, okay, probability z-score less equal negative 2.06, and that is equal, okay, 0.4803, and you round up based on requirement. So from question number 6, we are jumping to question number 8 because 7 is practically working with table. So I didn't cover that question. You can do it. Question number 8. So this is also working with table. It's just between areas. That's why I wanted to just show you how to do it one more time. All right. So 0 and 0.225. Z-score equals 0, that's right in the middle, average, and let's say 0.225. So I need to find this area, and then I need to find this area and subtract from each other, and I will get the shaded area. Let's go. Probability of z-score less equal 0, it's going to be 0.5, right? Probability of, you don't even need to go for this to the table. Every time z-score is equals 0, it's a 50% because we have bell-shaped graph. So when it's 0, 50-50. Probability of z-score less equal 0.225. If you look in the table, it's going to be, and obviously you're going to look in the positive table, it's going to be 0.591. Okay, question number 10. Let's solve question number 10. So what do we have? Assume a member is selected at random from population represented by the graph. Find the probability that member selected at random is from shaded area of the graph. Assume that the variable x is normally distributed. Okay, we need to find practically x That is, we need to find probability, that's what asking, probability of any x in the shaded area, which means we need to find probability of x greater than 200. Hold on, it's looking horrible. 200 less than x less than 475 equal question mark. That's what we need to find. Remember how we go from x to probability. From x we need to find z-score first, because only z-score has access to probability, right? Table. And if we have probability table, we need to find x. From probability we go to z-score, from z-score to x. Right now we are using this path. We are given x, going to z-score, from z-score to probability. Okay, let's write down x1. So we are going to calculate z-score first, right? We need to find this z-score. Okay, what do we have? x1 is equal 200, x2 is equal 475. Mu, excuse me, mu is equal 511. No, I'm not coronavirus infected. I'm kidding. And sigma is equal, sometimes you want a little bit laugh because it's too serious material. 105. Okay, sigma is equal 105. Here you have this data. So let's find z1 and z2 for x1 and x2. Z-score 1 is equal x1 minus mu over sigma. Z2 is equal x2 minus mu is sigma. All right, so what do we have here? x1 is 200 minus 511 over 105, and that is equal negative 2.96. Z2 is equal 475 minus 511 over 105, and that is equal negative 0.34. So we have this z-score 1, z-score 2. Now let's find the probability. So the shaded area, it's going to be probability of z-score 2, right? That is z-score, that is less equal negative 0.34 minus probability of z-score 1 less equal negative 2.96. And this is equal 0.0017 minus 0.0015, and the answer is going to be 0.0002, and that is probability for x is greater than 200 and less than 475. All right, so this was question number 10. Moving to question number 11 and 20, because they are going to be identical. There we go. So it's going to be same way, absolutely same way. So you are going to find this area, find this area, and then find, when I say area, I mean probability, because they are identical. I mean, same way we solve area, it's the same thing, probability. All right, so writing down x1 is equal 27. Again, we need to find the probability for the members that randomly chosen from shaded region. That's all I need to know. And all data is given here. x1 is 27, x2 is 33, mu is equal 20.6, and sigma is equal 5.2. Here we go. Right? Okay, so Z1 is equal x1 minus mu over sigma. It's equal 27 minus 20.6 over 5.2. And that is equal 1.23. Z2 is equal x2 minus mu over sigma, and that is equal 33 minus 20.6 over 5.2, and that is equal 2.38. Okay? Next, we need to find their probabilities, right? So probability for Z1 less equal 1.23 minus, or I might as well put the x values. Hold on. So x, that is greater than 27, less than 33. It's going to be equal, so probability of Z1 less, let me see, this doesn't look like 27, hold on, let me redo it. I know my handwriting is not the best. So Z1 is less equal 1.23 minus probability of Z score 2 less equal 0.46, and that is equal 0. Wait a minute, I think let me see, I think I should put the opposite, because this is positive 1. It's going to be, yeah, Z2, of course. This is Z2, this is Z1. So I have to take Z2 minus Z1. Yeah. I'm human too, you know, so I can also make mistake. Especially myself, I do a lot of silly mistakes. And it's not because I don't know my subject. I know my subject very well. It's just not attentive. Sounds familiar? Okay, so let me see. Z1 less equal 1.23. Z2 is less equal 2.38. Okay, now it feels much better. So from here, what do we have? 0.99913, this is for this one, probability, minus 0.8907, this is probability for this score, and the result will be 0.1006. So this is practically x greater than 27, less than 33, put parentheses, here is probability. And we got the answer. So, okay. Moving to next question. Question number 13. So what do we have for question number 13? It says assume random variable x is normally distributed with mean mu equal 50. So mu is equal 50. And standard deviation is 7. So we need to find probability of x greater than 39. It's greater than, which means we have to subtract from 1, right? So first of all, let's do this. We need to find z-score, probability of z-score. That's okay. Z-score here is equal x minus mu over sigma. X is 39 minus 50 divided by 7, we get 1.57, and then probability of z-score less equal 1.57 is equal 1.57. If you look in the table, it's going to be 0.9418. All right, but this is probability. This is equal probability for x less than 39, but we need greater than 39. So what we're going to do, so probability for x greater than 39, we are going to take 1 minus 0.9418. That will be 0.0582. Why? Because if this is my 39, we need to find this area, right? So therefore, since z-score is the same for right area and left area, so we find this one, and then from 1, total is 1, right? Subtract this probability 0.9418, 0.9418, and you will get 0.0582. Okay, next question. Question number 14. What do we have here? So we need to find probability for x that is less than 76, the greater than 76 and less than 82. Okay, we have sigma is equal 44. Okay. And mu is equal 86. All right. So x1 is equal 76, x2 is equal 82. All right, so let's see what we're gonna get. So to find the probability, we need, for x, we need to transfer to probability of z-score, right? So we'll find out our z-score and plug it here, because we need transfer x to z-score, because only z-score has access to the table. Okay. So, z1 is equal 76 minus mu 86 over sigma, which is 44. That will be negative 0.23. Next, z2 is equal x2, which is 82, minus mu, which is 86, divided by sigma, which is 44. And we get 0.09. So here we are getting negative 0.23, and here we get 0.09. Okay. All right, once we got z-score, we can practically find the probability. Probability of z-score less equal negative 0.23. You can find 0.4090. Probability of z-score less equal 0.09. It's going to be 0.5359. Okay, once we have, we're going to subtract, because we need to find the shaded area, right, between these two z-scores. So we need to subtract from each other. Okay, And that's going to be 0.5359 minus 0.4090. And that is our x greater than 76, less than 82 probability. All right, and it's going to be equals 0.1269. Okay. I don't like this 7. Let me write it nice. Okay. Question number 15. Question number 15. Find z-score that has 70.2 of the distribution's area to its right. So it's crucially important to its right. So 70%, it's going to be this somewhere, 70%. So we need to find this area first, right? Okay, to find this area, what we need to do? We need to do, so first of all, 70.2% is decimal notation 0.702, right? 0.702. Then to find this shaded area, we need to subtract, correct? So why we are finding while we need to do the right one? Because the table shows the left one, that's why. But z-score is going to be the same anyway, so it doesn't matter. Okay, you take area left. It still will show z-score that is limit bordering area to the right also. So z-score for, oh yeah, I haven't subtracted. Okay, I mentioned it and didn't subtract. 1 minus 0.702 is equal 0.298. All right, so z-score for 0.298 is going to be equal negative 0.53. This is probability. So probability of z-score 0.298. That's another way to write down. Or you can put less equal 0.298. And will be negative 0.53. Okay. Next. Question number 16. Question number 16. Use the standard normal table to find z-score that corresponds to cumulative area 0.0612. Cumulative area 0.0612, that's a probability. That is probability. Let's say this is the area to the left. It doesn't say to the right. That means we assume to the left. It says if the area is not in the table, then use closest one. I already mentioned it. If the area is halfway between, then you need to take halfway between corresponding z-score. Okay, so if you go to the table, again, you need to find the closest number to 0.0612. Which table will you go? Of course, you will go to negative z-score table because you have 0.06, which is 6%. It's less than 50%, right? From 0 to 50%, it's a negative z-score is serving. From 50 to 100%, it's a positive z-score is serving. So since we have 6%, we are going straight to negative z-score. And horizontally, you will see negative 1.5. Vertically, you will see it's between 0.04 and 0.05. So z-score, it's going to be z-score for 0.0612, it's going to be equal negative 1.545. Okay. Next one, 17. Okay, let me see what's gonna happen on 17. Here it is. In the recent study of world happiness, participants were asked to evaluate the current life of scale from 0 to 10, where 0 represents worst possible life, 10 represents the best possible life. Okay? The mean response was 5.4. What else we have? A standard deviation 2.4. And we need to find probability. What's what's the response? What's the response is x. We need to find x. X is equal question mark. The only thing we are missing, z-score. And z-score we will have it. So z-score we will have from these percentiles, 86%, 60%, first quartile, it's a 25%. Okay, so let me write down this first of all. Z-score for 86% is 0.86. If you look in the table, it's going to be 1.08. Okay, second one, Z-score for 0.6, it's going to be 0.255, and Z-score for first quartile, it's a 25% or 0.25. It's going to be equal negative 0.69. Okay, because 25%, it's a less than 50%, therefore Z-score is negative. 60%, 0.6 is a 60%, greater than 50%, therefore Z-score is positive. The 86%, which is 0.86, is greater than 50%, therefore it is positive. Okay, now all we have to do, this Z-score, plug in the formula for x is equal sigma plus sigma z-score plus mu. Okay, let me clean A because I'll plug this formula. And now I will go to solve one after another. Okay, A is going to be 2.4 times z-score. It's going to be 1.08. So would you like me to put multiplication like this? I just don't. Okay, multiply. And plus, because this is here, multiplication. And plus mu, 5.4. So, and result is going to be 7.99. Next one. B. I'm solving everything based on this formula. Okay? Sigma is the same. Sigma is equal 2.4 times, again, 1.8. No, actually, this score is 0.255. And plus 5.4. And we get 6.012. And see, x is equal 2.4. How much is our z-score for 25%? First quartile is negative 0.69 and plus 5.4, and you will get 3.74. Okay? Question number 18. They are same identical questions, so it's the same thing over and over. just because you are just learning, I accept that it can be a little bit confusing. Question number 18. The pregnancy length in days for a population of new mothers can be approximated by normal distribution with a mean 266, okay, days, and standard deviation is 10 days. So we need to find minimum pregnancy length. For A, we need to find X minimum. For B, we need to find X maximum. Okay, let's start with X minimum. For A, we are given top 11%. Top 11% meaning this is your 11%. Okay, so to find this area, we are going to do 11, which is equal 0.11, right? All right. So we are doing 1 minus 0.11. So to find the left side area, right? Because table shows left side, and that is equal 0.89. Okay, what z-score is matching? What z-score is matching to probability 0.89? Z-score for 0.89 is equal 1.23. Remember, if it's a probability, 0.89, obviously probability. We are looking in the body of the table, and it's going to be in positive table, right? 0.89. So you come here, it should be 1.2, and come here, 0.03. 1.23. Okay. So X from here, so X formula for X is equal Z sigma plus mu. Okay, we have Z 1.23, we have sigma, which is 10, and plus mu is 266, and the answer is 278 and 3. Now let's do second one, X max. Second one, X maximum. So this time we want bottom, right? Here was top, right tail. Here we are going to do bottom. Okay? So for the bottom, 0. Let me see. 0.66, it is going to be bottom, so this is your 0.66. Okay, so we don't need subtract because it's already left tail. So z-score for 0.66, in the table you will find z-score 0.42, and from here X is going to be equal, z-score is 0.42 times sigma, it's going to be 10, and plus 266, and we are getting 270.2. Okay, this is the answer. All right, next one, number 19. A vending machine dispenses coffee into a 20-ounce cup. The amount of coffee dispensed into a cup is normally distributed with a standard deviation of 0.05 ounce. do you see the business examples that where how much you can benefit from the statistical problems? Okay. So standard deviation is 0.05. You can allow the cup to overfill. When it's talking about overfill, it's talking about top 4%, right? We are talking overfill, it's the top 4%. 0.04, top 4%, which means this side is going to be 0.96, right? Okay. All right. So what's we gonna do here? Sigma 0.05, 4% we wrote down already 0.04. So we need to find z-score, correct? Z-score for 0.96. And if you look, it's going to be 1.74. So it's asking to find the average, right? The mean amount of coffee. So from formula, x is equal z sigma plus mu. So from here, mu is going to be equal x minus the score sigma. How much is our x? Let me see. Yeah, 20 ounce. Here it is. X is equal 20. So mu is going to be equal 20 minus 1.74 times sigma 0.05. So mu is going to be equal 19.91. Okay, the average amount is going to be 19.91 ounces. And the last question, using a table of cumulative area under the normal curve to find z-score to the given cumulative area. Okay, and then it's telling you if the area is not in the table, use the closest one. If it's halfway, take in between corresponding z-scores. So we need to find z-score for probability 0.045. Couldn't be easier. Look in the table 0.05, which is going to be negative z-score table, and you will get the answer negative 1.7. All right, so I'm done. Now it's your turn to go over to understand, and then so you can do well on your group activity and test. And I will start recording next topic that is coming. Okie dokie then. Thanks for watching.